Hello everyone, I am Anish and today we are going to solve another circuit which is an R and L circuit with a diode connection. So here we have a current source which has a pulse type waveform and we need to find the average diode current, right? We had another question like that RC which had to find the average diode current. Now this is RL. So here what we have to do is first we have to calculate for t is equal to 0 plus what is the current through the circuit, right? So as t is equal to 0 plus, here as we know diode won't allow any current to flow in this direction, cathode to anode, right? So only this I1 has one direction to flow, which is this one. So as at t is equal to 0 plus, what will happen is the circuit will look something like this: R, L and C. So as on current is only flowing through this, right? So what will happen is we know that inductor has this property that it doesn't allow sudden change of current. Now but as this current source will only push this current to flow through this, so it has to change this current, which will only happen when an impulse voltage happens through this inductor, right? Which will occur. So impulse voltage will come across this inductor and this current will flow through this. Now at this instant, no, what is the time constant? We can check it from another concept also. What is the time constant for the circuit? The time constant for the circuit will be L divided by R equivalent, right? So if we just remove this inductor, now we know for a current source the resistance is very high, input resistance is very high. So here this is almost like open circuit and we are calculating the R equivalent from here. It's almost equal to infinity, right? So if L by infinity, which is almost equal to 0, so the current through the inductor will settle in no time. It will get to IP in no time. So as the inductor is charged to current IP, so up until t is equal to 0, from t is equal to 0 plus to t is equal to t on, right? The current through the inductor will be IP only, and the current through the diode is 0, as no current is flowing through it. The current through the diode is 0 up until t on, t on IT. So here all this happens, and what is the voltage across the inductor, right? What is the if you want to calculate the voltage here, V naught of t, what is V naught of t? So V naught of t will be only one impulse across the inductor coming, then it will be 0. Why it will be 0? Because here if we find the derivative of this, right, we know that VL is equal to L dit dt. Now as the current isn't changing, so the slope of it will be 0, hence VL will become 0. Only one impulse will come across at t is equal to 0 plus, right? So after this, at t is equal to t on, what will happen is this diode will come in action because this current source will be opened. Here the circuit will disconnected and this inductor will want to continue flow its current, right? So the circuit will look something like this. Now we are considering almost ideal diode with some resistance RD. It doesn't matter because the time constant won't change much, RD and L. So here if you calculate the time constant, right, of the circuit, time constant will be L by R plus RD, which is only equal to L by R only. Almost RD is very low. So here we have some big time constant because we already have mentioned this constraint, right? T is very less than L by R. So it will discharge very slowly, but it will charge very fast. This also occurred in the previous question, right? This also happened in the previous question. That's why they put this given this condition. Always when in an interview or somewhere, always check for conditions something like this. This may come in really handy. This can come as a hint for you. So after this, what will happen is uh, we have plotted the current through the inductor. What will happen? The current was constant, right? Then it will very slowly discharge, then again it will charge instantly, then again discharge. This will keep on happening. Now what were we plotting? This one was I agree ID, right? So ID will come into action now. So the current through the ID will be, it was 0 till t on, right? Just let me write it a bit clearly. It was 0 till t on, then suddenly it will get this current and will start discharging, then again it will become 0, and this one. Now, like, the main question asked was to current the calculate the average current, right? Average diode current. So for that, like, if we like just linearize this part, the discharging time is very low, we can just assume this voltage to be almost, sorry, this current to be almost constant, right? So what will be the average current? The average current will be like the area under this curve, right? Under one time period. So what is the area? Area is like, this is IP. So IP into t on, sorry, writing this wrong, uh, t minus t on divided by d, which is equals to IP into 1 minus t on by t, which is equals to IP into 1 minus alpha, where alpha is the duty cycle of the circuit, right? So this will come out to be the average value of the inductor current. So sorry, not inductor, so diode current. So now the question is over. If you want to like complete more, if you want to like know the output voltage, right, the VL. So what will happen is, inductor will produce the voltage in some like opposite direction, right, to like continue to flow the charge. That is the current. So here is, at initially we had an impulse, then it was 0, then again it will go here and suddenly it will decay. This voltage is only equal to the like resistor voltage, right? Resistor will have a drop IL into R. This is the same voltage, right? It will then decay exponentially. Again, one impulse will come up, which will charge, which will energize the inductor instantly. Then again we'll get 0 voltage, and then again this cycle will follow on, right? So this will be the output voltage waveform. This will be the whole like explanation of the circuit, right? I think that's it for this video. If you have any more doubts, you can just post it in the comments below, and you can send it to my Telegram channel also. Thank you.